this class we will see the importance of navigation channel. This figure shows the ship, and the width of the channel here is about 135 meter, here this is about 215, here it is 335 meters. Suppose there is no cross current or wind, the ship will be moving in this direction. It is a course made by the good ship. Suppose there is a current in this direction, the ship will tilt towards this side, then it will move like this, then we have to use the rudder of the ship to make it within this. So if you have larger width, there will not be any accident that will take place. If it is a smaller width like 135 meter, it is just sufficient for a vessel of 40 meter width and 290 meter length. See, another important thing for design of navigation channel as well as the berth is what is the wave disturbance. This wave disturbance within the harbor should not exceed the following tranquility conditions. Here we call one parameter of the wave, that is the maximum significant wave height in meters. I will discuss about significant wave height in another class, but to make it very simple, significant wave height is average of 1/3 of the highest wave heights. Suppose there are about 100 wave heights, you take top 33 wave heights and take an average, that is called as a significant wave height. Maximum is coming because we are taking the top 33 waves. The units are important, that is in meters. So depending on the type of the vessel and the location where the vessel is, whether the vessel is at the berth, whether the vessel is at the training basin, whether the vessel is at the offshore mooring. Offshore mooring means in open sea condition, there are many structures, berthing structures that are built in offshore berthing structures. In addition, we have this anchorage, that is we do not have a direct berthing port, we have an anchorage port where the vessel will be moved in the offshore, and then we load and unload from the offshore mooring by small tugboats, small barges to the inside lagoon type harbors. So we will first discuss about general cargo. General cargo, the maximum wave height that is permissible is about 0.65 meters, whereas in the training basin where the vessels turn, there it will be about 0.9 meters, and if it is offshore mooring it is 1.5 meters. Then if it is a bulk cargo, maximum significant wave height is 0.9 and training basin is 1.2, 1.5 for berthing and 2.5 for operation. Then we have the container cargo, it is 0.65 meter at the berth and 1.2 meter in the training basin. And bulk cargo you need you can operate at a higher wave height, whereas containers you can operate at a lower wave height only, because the container cranes and the lifting and other things, generally we need smaller wave heights for container cargo compared to bulk cargo. Then we have trawler and fishing boats, then deep sea tugs, dredgers, supervisor boats. To summarize, in offshore mooring generally this is for single point mooring and things like that, and there we can permit higher wave heights for operation, whereas inside where the berth is very close to the structure, any movement of vessel, undue movement will create disturbance, so we need smaller wave heights. Then we have to talk about the entrance to the breakwater, entrance given by what we have to leave the gap between the breakwaters. So this is another important parameter. If you give more entrance, the vessels will ply easily, but if you give more entrance, the wave heights what we are giving will be higher. So there should be a compromise between these two conditions. That is what it is written here. It should be minimum consistent with safe navigation and tranquility requirements. For medium vessels, that is vessels up to 150 meter overall length, typically it is about 100 to 150 meters. For large vessels it is about 200 to 250 meters. Next we will discuss about the width of the apron. Apron width means the width of the berth. So the width of the berth depends on the type of cargo, whether it is a general cargo and if it is one way traffic or two way traffic, that is the traffic on the apron. Apron means width of the berth. One way traffic means it is 6.5, two way traffic means 8 meters. Generally any berth cannot be less than 6.5. If you are using two way traffic for loading unloading, then you need 8 meters, but if you are using a one way traffic plus one truck, it should be 9.5 meters. One track plus gantry crane, that is the mechanical handling system. What I was telling earlier is road lines. Now we have a gantry crane, then we will have 11 meters. If we have two tracks and one truck, 13.5, two tracks plus one gantry crane, 15 meters. Then modern cargo berths, typically it is between 15 to 18 meters. Another thumb rule is whatever is the width of the berth, you provide that as the width of the apron, but typically about this code is developed in 1980. So recent days we have berths typically between 25 meters for general cargo and bulk cargo to 40 meters for container berths. Fisheries harbour it is 3 meters, container berth it is 40 meters. The bulk handling and other specialized berth depending on the cargo transfer equipment, that is rail mounted cranes. Typically the rail mounted crane, the track is about 18 meters. Here we have written gantry crane. These are all small cranes where the track width is about 6 meters. This is not for bulk handling, this is for general cargo, whereas for bulk handling it is about 18 meters. Nowadays we have mobile harbour cranes which are being used, that also need a width of about 20-25 meters. Behind the mobile harbour crane or I am sorry, behind the gantry cranes we will have the conveyors. So I will explain with a sketch what is the width required for this. For tanker berth it is by the marine unloading arms, what is required that should be provided. Another important parameter is the deck elevation. Deck elevation depends on various factors, but the main thing is the largest vessel in light displacement condition at high water, that is in highest high water you have the largest vessel in light displacement, and with smallest vessel fully laden at low water. The deck elevation should normally be at or above highest high water springs plus half height of an incident wave at the berth location plus a clearance of 1 meter. This deck elevation, when we talk, we have to include the depth of the deck also. So that is not very clear here, but please understand that the highest high water level plus half the height of the incident wave plus 1 meter clearance plus depth of the deck, we will have a deck beam and deck slab. So above that you have to provide the deck elevation. So this is related to the environmental condition, that is the high water spring, incident wave and clearance and depth of the deck, geometrical, whereas what we have discussed here is depending on the cargo transfer equipment. So your cargo transfer equipment should be able to access the vessel in various tidal condition. So considering that you have to fix the deck elevation, but prime consideration is this only. So then you have to make the cargo transfer equipment according to this, you have to design the cargo transfer equipment. Then another important parameter is what is the land area required behind the berths. So this is very important because the land space available is very less nowadays, so you have to go in for optimum space size. Generally container berths need higher storage area compared to general cargo, and this is given as 2.5 to 3 hectares and 8 to 12 hectares. Here we have not written anything about the capacity of the berth, but generally the general cargo berths is about 2 million tons, and this will be about container berths. 300 meter container berth will handle 300 meters into 1500, that is about 300 into 1500 is how much, it is about 4. I think 45,000 TEUs. So that is what we have to cater for. Then bulk cargo berths, it depends on the equipment handling and other things. If you want to see in terms of 1 million tons of cargo to be handled, we need about 2.5 to 3 hectares, that is what is required for a general cargo berth. If the cargo handling is fertilizer and things like that, then we have to go in even up to 8 hectares. Whereas for bulk cargo berth, if you have efficient handling, it can reduce for 1 million tons to about 1.5 hectares, and for 1 million ton TEUs to be handled, we need about 40 hectares. I think earlier I said 45,000, I think it is 4.5 lakhs. So 1 million TEUs if you want to handle, we need about 40 hectares. In foreign countries they have only 25 hectares for 1 million TEU. So what I am trying to say is in terms of tons of cargo to be handled. This we already discussed, what is the track gauge, this is 6 meters, this is a standard gauge. See, another important thing is there are 2 rails for the crane, one rail is on the sea side, another rail on the land side. We call what is known as key edge. Key edge means the face of the berth. The maximum distance of the key edge inclusive of fixed fenders from the outer crane track is recommended as 2.65 meters, that is what they have given. But the minimum distance also should be of this order only, because otherwise the vessel will hit the crane. So this 2.65 meter they have given maximum distance, but the maximum distance is nowadays increased, that is even up to 3.5 meter they are giving, but minimum distance should be about 2.65 meters. Then this is about the fixing of the rail on the wharf. The other things are about the mooring facilities. We have 3 mooring facilities that are described here. One is the bollard, another is the cleat, the third one is a capstan. We should know what should be the spacing of the bollard, that is at every 25 to 30 meter along the length of the berth, and this should be located approximately 0.15 meter behind the cope line of the berthing structure. Cope line means the face of the berth, so it should be located very close to the berth, about 0.15 meter. The spacing of bollard is about 25 to 30 meters. The cleat is for smaller vessels, and capstan is the one which is used in dry docks and other places to assist the movement of the vessel. So when you want to plan to complete, I will just run through this functional and operational buildings. So we will have traffic officers, we will have custom officer, deputy conservators officer and signal tower. The signal tower is very important. This is a navigation tower which controls all the vessels which are coming in and going out. You know about this air traffic controller, like that we have a signal tower, mooring master's office, dock master's office, sheds for cargo handling equipment, hazardous cargo shed, fumigatorium, this is to fumigate the cargoes like cotton bales and all, illumination towers, incinerator, these are transit sheds, warehouses, the fire station, this is also very important. So these are some of the buildings that are to be provided. So there is a very exhaustive fire protection requirements, this also has to be provided inside the harbor. Now we are coming to the end of this port planning. So in this appendix it is giving this table gives what will be the size of the vessel, that is in terms of GRT, what is the depth required and what is the length of the berth. So this gives an idea. So if you have a passenger ship of different sizes, what will be the water depth required and what is the length of the berth. Similarly it is given for freighters, then tankers. So for example if you take a 30,000 DWT, the depth required is 11 meter, the depth is different from the draft. The draft is 9 meter, typically 9 to 9.5 meter, depth is 11 meter, the length required is about 210 meters. So for 300,000 DWT vessel, depth required is 19 meters and the length required is 14 meters. So I have earlier shown in one of the lecture what is the size of the vessel, but now what I am giving is what is the water depth required and what is the length of the berth. For ore carriers for about 80,000 DWT, which is more economical nowadays, water depth required is 13.5, length required is 290 meters. This is only the guideline. So we will go to next lecture. The next lecture is on surveys. So this survey is very important. Before you do any construction activities, you have to carry out the survey, and the main focus of the berthing structure course is estimation of load, analysis, design, but to estimate the load we need to get some of the characteristics. Can you tell me what are all the site characteristics you need, what are all the survey we have to do, what are the parameters you require? You want to say something, what is that? No, the area means what is that you have to do? Survey means what are the survey you know, civil engineering students must be knowing, no? You know about topographic survey? What is topographic survey? You know about contours? The civil engineering students, you are doing some survey on the roads and all, no? You have completed. What is that you are trying to find out in that? What is that you are trying to find out when you do the survey? Who are all civil engineering students? Yeah, you have done the survey, no? Reduced levels, then
contours.
So you try to find out the levels at various points. That is called as a topographic survey. Similar thing if you do it in the sea, it is called as a bathymetric survey. Okay. Then you want to plan a harbor from the seaside, ocean engineering students, what are all the informations you need? You are putting a structure in the sea, what are all the sea parameters you have to find out? What is it?
Slope of the bottom.
What is it? Slope of the bottom. That is bathymetric survey. Bathymetric survey will give the seabed slope. What else? Tidal variations. How will you get the tidal variation? Tide table is there, but this is site. We go to the site and we want to find out the tide. We have an instrument called tide gauge. You place the instrument and measure the water level continuously and find out what is the tidal variation. What other parameter is required? Other students also can reply, because I have said so many parameters to affect the design of the structure. Huh? Wave height. So we have to measure the waves. How to measure the waves? Pressure transducer, or we have what is known as a wave data buoy. So we deploy a buoy in the sea and measure the waves. What are the other parameters? Tide, wave, one more important parameter is there. Current, we have to find the current also. Current means you have to measure both current velocity and direction. That is also there, we have a current meter. What is another important parameter if you are trying to design a structure, a building? Wind you have to measure. So you have to deploy a wind and then you have to measure. What other parameters are required? You want to design a building, what is the important parameter required? Huh? What is it?
Soil investigation.
Soil investigation you have to do. So this in summary the various studies that are to be carried out. Soil investigation is required. But soil investigation not only on the land, you have to investigate the soil on the sea also. You have to deploy in the sea and then carry out the investigation. In addition we get other parameters like temperature, salinity, so many other things also. So first we will see about the location. So we have to designate the site. So this is important, we have to give the designation of the site, just like everybody has a name, you give the name for the site. Earlier there was a lot of problems when we have the railway stations named after the political leaders and other things. So now most of the railway stations are named with the location, the village name, the existing village. You cannot create a new name for the village and give. Whatever is the village you have to give. We have a port at Gopalpur, the location, the small town nearby is Gopalpur, you designate the site as Gopalpur. We need this latitude and longitude also, then altitude also. Latitude longitude means I will explain with a figure, otherwise these are the two coordinates which will give the location. Altitude means it is a height. Then we should get the hinterland characteristics including neighboring towns or villages and prominent local features. Local features means it can be the if there is a hill, there is a lake, there is a river, there is a heritage site, all these things you have to see. The next, first it is the location, then the communication. Communication means what are all the existing highways, particular reference to state and national highways. This is very important because during construction, as even before construction, even to carry out the survey, if somebody has to go to that location, he needs to know what is the existing communication facilities, railway gauge, sidings and other facilities. So railway lines we provide a siding to many ports, so there is a separate line going that you have to give. Then inland waterways, quantum of barge and light rage traffic and air routes. So air traffic is also important because whenever you develop a port, the consultants either from India or abroad, they have to come to the site, so they may be coming by air, so this is also required. So these highways, rail and waterways are required for transport of cargo once the port is commissioned, and the air route also is required because sometimes some specific equipment required for firefighting or something, it has to be air transported. After apart from that location and communication, we now go into the technical requirements, that is a bathymetric survey. It will be done for different site conditions, it can be on a open lake or in a river or inside a harbor basin. So each case the bathymetric survey is slightly different, survey methodology for different site conditions, selection of survey equipments, and there are some advantages using this GPS for bathymetric survey, that also we will discuss. Now we will see what is GPS. GPS is a satellite based radio navigation system to show the position of an object on or near the earth. Nowadays the cell phone also has GPS, you can find out, but what is required in GPS when you go for a survey is accuracy. The accuracy requirement varies. If it is a handheld GPS, accuracy may be about 10 meters. So if you take the GPS today and it shows some latitude longitude, then after some time the same location you may not get the same latitude longitude. So you have to move maybe about 5 meter or 10 meter to get the same latitude and longitude. But we have a differential GPS which is having very high accuracy, they claim it is up to 1 meter. So once you have this high accuracy GPS, then your position fixing is very good. So it is a principle of GPS is given, it is to place high frequency radio transmitters in space. A transmitter high above the earth sending a high frequency ratio wave with a special coded signal can cover a large area. The differential GPS or good GPS survey, we get the signal at least from 3 satellites, not from single satellite. You have a base station and you have a ground truth data to cover this. This shows the photograph of a handheld GPS. Whenever we go for any site visit, we carry the GPS along with us. This is one of the essential equipment with which we will go. So there is various requirement for the survey. When you do a bathymetric survey inside the harbor basin, what is shown here is not at the planning stage, but to the maintenance, dredging and other things. At that time the harbor basin is well established, so you make key points on the open space. See to spend some more time on this, there are 2 types of bathymetric survey required. One survey is required once the port is commissioned, another survey is required for greenfield ports where we have to do the survey. I have some examples which I will show you later. So once you establish a port and you want to do a survey in a harbor basin, you have to mark key points in the open sea. The high accuracy is required in positioning of the survey points. You need closer grid spacing. Grid spacing means what interval you have to find out the depth. So to be simple, bathymetric survey means you have to find out the water depth at different locations. Can you tell me how close you want to get the water depth? Guess. What will be the size of harbor basin approximately? Typically about 1500 meter by 2000 meter is normally the size of the harbor basin, 1500 by 2000 meters. How close you have to measure water depth? You can get it from the standard textbooks, but please think about it. Huh? How close?
50 meters.
50. Then any other answer? 50 meter is very close to the answer, but normally what they do is they have some transects every 100 meters or something like that, grid lines, but each grid line they make very close spacings, 25 meters and things like that. It is not uniform. Uniform also is okay, you can do it. Then we use a survey vessel, then proper alignment of survey vessel irrespective of wave and wind is important. That is you go through a grid. What I am saying is every 100 meter you have a grid, the vessel has to move in a grid of 100 meters, it is go along those lines. So those lines it should go properly. The scope of the survey, what is the scope? This is a preparation of bathymetric chart for the proposed area and estimation of dredging quantity. This is the maintenance dredging quantity. What we normally do is we prepare the bathymetry, find out the water depth and see whether the water depth is as per the requirement. If not, you have to find out how much soil has to be dredged for that purpose this will be used. So this is the base station, this is the satellite, this is the vessel, there is a GPS antenna, there is a sounding equipment. So this can be different types are there, it's a acoustic transducer only, the various types are there that we will say. One is called as a echo sounder, another is called as a sounding rod. So this sketch explains the vessel is moving in water, water line is not marked here, there is a seabed here, there is a GPS that is having an antenna, it receives the signal from the satellite, base station also receives the signal from the satellite. So it is called as a differential transducer. We have two GPS, one on the base station that is on the land, another on the vessel. It receives the signal from the same satellite, then matches the signal, make any corrections required for the position, then you have an echo sounder which is deployed below the vessel, it sends acoustic signals from the seabed, it receives back and find out the water depth at a particular location. All this data is stored in the data process unit. Though it looks simple, there are certain problems associated with that, some corrections are to be made. When the vessel is moving, the vessel will have some oscillation. So we need to have what is known as a heave compensation. Heave means the motion of the vessel in the vertical direction, that is called as a heave. The vessel can also pitch and it can also roll, that is a, there are three translation motions, that is a heave, vertical motion, surge and sway is perpendicular to the screen. So three translation and three rotational motion, one is called as the pitch, rotation in this direction, another is yaw in the plane of the water, another is the roll motion perpendicular to this. So 6 motions will be there, generally we have to give only for heave compensation. Another is the tidal level will vary throughout the survey period, that also you have to make some corrections. Then there is some sensitivity of the equipments, anything less than 2-3 meters the echo sounder will not work, even this has some physical, I am sorry what is that, the equipment for the echo sounder which will be deployed below will have some dimensions. So if this is very close to the seabed you will not get the signal. So minimum water depth it can measure below the vessel bottom is about 2 to 3 meters only, I am sorry less than 2 to 3 meters this will not measure, more than 2 to 3 meters only it will measure. So what are the problems faced during survey and precautionary measures? Oscillation of boat, this shall be checked by the heave compensator of echo sounder, power check shall be carried out for the echo sounder calibration, this is important, you have to do the calibration. The DGPS should get proper satellite signals, the boat shall be carefully maneuvered along the straight line in the grid, these are the various factors that are required. This shows the bathymetry chart prepared and given by naval hydrographic chart. This is Bombay and here we have this Elephant Island and this is the place for JNPT. This is the navigation channel which goes through this. The survey we have to carry out both in the navigation channel as well as in the training circle. Here we have the harbour, Mumbai harbour is on this side, this is the Arabian Sea, this is north, this is on the western side and we have the Bombay harbour protected by the Bombay island from the Arabian Sea and JNPT is well protected, we have the Elephant Island that is also protecting, in addition the whole Bombay island is protecting the JNPT. You have the navigation channel here, so you have to do the survey at very close interval at these locations. The scale is also important, what scale you prepare the survey. This shows Chennai, this is your Jawahar dock, this is your Ambedkar dock, this is your Bharati dock, this is your entrance channel, this is your training circle I was talking about harbor basin. This is the outer harbor basin, this is the inner harbor basin, this is the breakwater, this is the true north and this is your eastern side, and here you have the fisheries harbor which is located here. So this shows the contour lines, bathymetric contour lines. What is shown here, this is the water depth, it is marked here, and this is your navigation channel, this is your training circle. It shows the layout for Visakhapatnam harbor, both the inner harbors, training circle, entrance channel for the inner harbor, then the outer harbor, breakwaters, the fisheries harbor. This contour, I think most probably this must be about 10 meter contour, what is marked here. Here we have the opening, it is not a shore connected breakwater, so there is a sand trap here, the entrance channel here, this is the training circle. So this I think now you know what is the importance of the bathymetric survey, that is you have to prepare the survey and give it to the ship master so that he knows where the water depth is, required water depth is available. I think last week there is a capsizing of this passenger cruise vessel, no? All of you are aware, have you seen the newspaper? What is the reason for the failure? Accident?
To one side of
It hit some rocky patch, because that is what they are telling so many reasons, but one of the reason is this has when it has gone to a place where sufficient water depth is not available. When it is moving to a place where the sufficient water depth is not available, it will come and hit, that is what it is happening. So that is the importance of that. So some of you have told that subsoil investigation is very much important, that is a geotechnical investigation. Land based geotechnical investigation is very easy to carry out, you can carry out, but in the open ocean it is very difficult to carry out. So we are using what is known as a shallow seismic survey, this can be used on the land also. So they are using, this is the trade name of the equipment, acoustic sub bottom profiler, this is manufactured by some company, this company name is given, this is used for the shallow seismic survey. This is being carried out at a location in Andhra just south of Vizag. This survey is carried out by this company, this is carried out over an area of 2 kilometer distance along the coast and 3 kilometer distance into the sea, and the grid spacing is 50 meter. The all transects were planned in perpendicular to the coast. So what it gives is, it gives what the deposit is, it does not give below the seabed, but at the seabed what is the deposit it gives, the deposit can be silty sand, sand and compact sediment formation. They have also found out two ridges, one is the near shore ridge which is observed at around 750 meter from the coastline at 11 meter water depth, and it outcropped, that means it has come out of the seabed, above the seabed with a relief of 4 to 5 meter above the seabed. So this is called as ISO patch map based on shallow seismic survey. This distance is about 2 kilometers, this distance is about 3 kilometers. ISO patch means just like contour, these are the lines joining. These lines when they join, now what it shows is, it is not very clear from the figure, when you do a shallow seismic survey it should be understood along with the bathymetric survey. So you know the seabed, below the seabed what is the distance below the seabed where we have the hard strata, it can be rock, it can be some other material. So when you send a acoustic signal, I said in the echo sounder, it goes to the seabed and gets reflected. Shallow seismic survey is similar to that, but it goes below the seabed, and where it occurs, hard strata occurs, from there it comes back. This is clear to you. What we need in geotechnical investigation, where you have the very good strata, that is what we need. So what it gives is, suppose the seabed is minus 6 meter, it goes only another 2 meters and comes back, that means at 2 meter below the seabed you have hard strata. Isopatch line shows let us say that this is a 2 meter below the seabed line where you have the hard strata, and this is an outcrop. Outcrop means submerged outcrop below the seabed, below the water level, above the seabed some rock is protruding, and these are all rocks which are available. These are all some sediments what is existing, that is what it shows is not only the depth at which you have the hard strata, what is the type of soil between the seabed and the hard strata, that is also shown in this seismic survey. So the different color shows, the black color shows it is a rock that is there between the seabed and the other places. So you please go through this sketch separately. One of the information you can get is when you have, once you have a submerged outcrop, this see, this is for a seawater intake and outfall system. This is a landfall point, it is called as LFP, landfall point for the seawater intake. This is the place where we get the water from here. At this location the water depth may be about 11 meter or so. So here we have the rock below the seabed, but here we have the outcrop. So when this is the discharge, so this is the effluent discharge pipeline, this is the seawater intake pipeline. Since we have the outcrop here which was originally decided, we have shifted this outfall line from here to this point. Please go through this sketch and we will discuss this later. Thank you.